Good morning and welcome virtually to Old Dominion University and its remote experience for young engineers and scientists program known as REYES. My name is Giovanna Gennard, co-chair of REYES, and I will serve as your host for today's session on a career in ocean science featuring Ray Toll. The purpose of the Global REYES program is to offer free virtual learning experiences that increase science literacy, inspire and train future generations of STEM-age students. Today's discussion with Ray Toll offers us insight into his professional journey as a scientist, advancing research, education, and ocean policy. Throughout this webcast, you may submit questions through the Q&A box on your Zoom screen, and following his presentation, we will answer as many of your questions as time allows. It is now my pleasure to introduce our guest speaker, Ray. Ray, would you please turn on your microphone and video so we can see you? Hi, Ray.
Good morning.
Ray Toll is a retired Navy captain. He has worked in the fields of meteorology and oceanography for his entire career. He chaired Oceans 2012 in the Hampton Roads region of Virginia in the US, helping to usher in a concerted whole-of-government regional effort to address coastal resiliency that continues today. He was president of the Marine Technology Society and served on the MTS board. He's the former director of coastal resilience research at Old Dominion University, and he holds a Master's of Science in Meteorology and Oceanography. Currently, he is co-chair of Oceans 2022, which is endorsed by the United Nations Decade of Ocean Science for Sustainable Development. This event also highlights the international and national community in scientist leadership and integrated ocean observing climate change and sea level rise. He's also authored several papers on the Navy's operational global atmospheric prediction system and has worked with the National Oceanic, NOAA is how we know it today. So please join me in welcoming Ray Toll to REYES. Welcome, Ray. It's great to see you.
Thank you so much. And what a wonderful introduction, Giovanna. Much appreciated.
Absolutely.
Good morning, everybody from the US East Coast. I'm not sure exactly where all of you are, but hopefully it's at a convenient time. I have notes I'm going to share, no slides, so I'm hoping you'll be inspired to ask questions. And if there is any follow-up, I'll be glad to ship it to you via text or email or whatever. But my notes today, I'm going to be not showing slides. I'm going to be talking about from my notes. I'm going to define the two sciences that I've devoted my life to. It's meteorology and oceanography. It's a unique combination that not too many of us have pursued to get two disciplines together, but I have a master's in both. I want to talk a little bit about my research from my master's degree from the Naval Postgraduate School. Then I'm going to talk a little bit about how my career in meteorology and oceanography has been divided up into three. My Navy career takes the preponderance of the time of my life, my adult life. I've also spent 10 years in the private sector, and for the last, since 2012, I've been at Old Dominion University. I want to talk a little bit about the whole of government pilot project that I worked with the Obama administration from 2014 to 2016. As Giovanna mentioned, the Oceans conferences, I want to talk a little bit about Oceans 2012, which I chaired in 2022, which is upcoming in 2 months. Then offer some challenges for all of you as we pursue the grand challenges, as I call them, about the science of our blue planet. So first of all, meteorology and oceanography. I often tell people that my job was to look from the top of the atmosphere to the bottom of the ocean. So we're not talking about space science necessarily, although there's some overlap, but I go all the way to the bottom of the ocean. Meteorology and oceanography, the good news there is some similarities. It's just a difference in the science in terms of time and space, but it's all based upon physics, fluid dynamics, chemistry, biology. So you can see there's an awful lot of multidisciplinary involved in the Earth, what really are Earth sciences. There's an awful lot of math for those of you that like math. If you want to pursue either of these degrees, you hopefully will get a good solid math background before you begin your journey, because you will be taken all the way through advanced partial differential equations and some pretty pretty intense fluid dynamics because it's really all about the fluids as they move, either whether it's water or air. In meteorology and oceanography, you can teach, you can do research and development, or in my case, I was mostly operational. What does operational mean? Operational is a sort of a 24/7, 365 view of how the atmosphere and ocean are changing because they are fluids, they are changing all the time. And if you have what I call situational awareness, you can make your predictions and focus your predictions on whatever it is that's happening at the time that you're trying to support. In my case, many of the Navy missions over the course of my time in the Navy worldwide. My thought here about climate, the average weather on ocean, I want to just share these with you. There are four basic principles that I look at. Climate is determined by your latitude. So that's kind of obvious. How far away are you from the equator? How close are you to either pole, north or south? Ocean currents, topography, and land-sea distribution. You will see all four of those come into play as I talk a little bit my Navy career as an operational meteorologist serving the fleet. My master's degree was from the Naval Postgraduate School. I got my undergraduate degree from the University of Utah. I was on active duty at the time and I was interested in pursuing meteorology. At the time, it was a boyhood ambition going back to 8 years of age when I really and truly was fascinated by weather changes. I always thought that it was the closest thing to pure science because it fascinated me and it continues to fascinate me today. So when I was on active duty in the Navy, I got the degree on active duty. I had to apply for it and got it. And then I got my commission as an ensign in the Navy. And then from there, I went on and got my master's. And that's when I first picked up oceanography, which combined with the meteorology. So the nice thing again is that there are similarities in the fluids and how they behave. For me, the meteorology, the master's degree that I pursued was studying rapid storm development off the East Coast, or we call them rapid cyclogenesis or an atmospheric bomb, meaning that the low pressure storm exploded off the East Coast. This was a 1984 case study that I did, and I was able to determine that there were a combination of energies that made that bomb happen. There is something we call baroclinic instability, which is your higher mid-latitude storms, which involve your traditional cold fronts, warm fronts, and what is known in literature as barotropic instability, which is tropical, which is the theories of how a tropical storm, hurricanes develop. The combination of the baroclinic and barotropic instabilities I was able to prove in my master's degree were equally important, one over the other, depending upon the phase of the development of the storm. But the storm spawned hundreds of thunderstorms, dozens and dozens of tornadoes, and winds that were storm up to 50 to 60 mile, actually hurricane force winds. So it was a big deal. So today that's research has continued on because those two instabilities continue to be the main reason why we see development of various storms, whether they be hurricanes or what I call mid-latitude storms. So let's talk a little bit about my three careers. Remembering that as a meteorologist and oceanographer, these were boyhood dreams. And I felt that both of these disciplines were perfectly accommodating to one another because you obviously can't look just at the weather without worrying about the ocean and vice versa. The two interact all the time. And especially when it comes to climate and climate change, we know that the ocean drives the atmosphere over the longer term, but over the shorter term, it's the atmosphere that's driving the ocean. So there's always this what I call air-sea interaction, which is where we live and breathe and live, and that's where most of the action occurs. The fluxes between both atmosphere and ocean determine what kind of weather, what kind of climate change we're about to have happen. My Navy career went from 1971, right out of high school, to 2004 when I retired. So that's 33 years. I served. I joined the Navy in 1971 because I had that compassion without the resources at the time to get that degree. And I knew that I had to leave where I was born and raised in Cleveland, Ohio, to get the degree. I had to move. I had to leave, and I didn't have the scholarship monies or the resources to move out of town. The Navy provided me a ticket, but it took me a little while. After basic training and living in the Philippines for 18 months as an aircraft maintenance guy, I was applied for the degree. It was an ocean commissioning program. So when you enlist, you're on the active duty clock. You were eligible to apply for this commissioning program, which got you your degrees, but then you owed the time back to as an officer. Well, the good news there is I was able to get the degree and then get into the Navy's Meteorology and Oceanography career track and program. The Navy has, as you all well know, submarines, ships, and aircraft. My community track in meteorology and oceanography served all three of those key pieces of Navy as well as intelligence. So I always thought of my job as a force multiplier, where you could actually help your mission and deter your so-called enemy by having armed with the information of what the environmentals might do to your tactical and operational mission. And at this point, it was really at sea. So my career took me to Hawaii, and then I worked at the Fleet Numerical Meteorology and Oceanography Center, where I learned all about modeling. Then I got my degree, and then from there I went to the Trident Submarine Force, where I went all the way down to 1,000 feet, and I taught the submariners all about physical oceanography, what currents, tides, ocean fronts. There is an analogy to the ocean when it comes to fronts, and the difference in salinities dictated how easily it would be for a submarine to remain covert, or if they were trying to find somebody, because it affected the sound. Sound moves faster in warmer water and slower in colder water, so there's a lot of reflection and refraction that can distort or enhance, especially if the sound is in a channel, to either extend or degrade your abilities, your detection ranges. So it was a cat and mouse program, but I was the first for the Trident submarine community and submarine Spanger and outside of Bremerton, Washington, to do this. And it was probably one of the career highlights that I ever had. I went from the submarines and operating under the water to the USS Nimitz, for the first of the US Nimitz class carrier program, which still exists today. I was able to do carrier takeoffs and landings, and we were in the first Gulf War. So the key there was 6,000 of us on that ship, and we went from this west coast all the way to the Persian Gulf and back. And I think the challenge for you all is to understand, when I go back to what are the four ingredients for climate: latitude, ocean currents, topography, and land sea distribution. For me, the key was keeping our airplanes safe and returning, but able to support the mission of whatever they were doing, whether it was dropping bombs, whether it was surveillance. The most important thing was getting everybody back aboard safely and enhancing their mission. So I had to get the winds right. I had to get the temperatures right. I had to get the humidity right. And going from off San Diego, off the Pacific Northwest, through Hawaii, into the tropics, the China Sea, the Philippines, Indian Ocean, Persian Gulf, and then back. You can imagine how all of the challenges associated with weather prediction, how much it changed, and how adaptable you had to be. You had to stay on your toes to understand the data and understand the dynamics of where we were and what was trying to be done. From the Nimitz, I then pursued. I was in Washington, D.C., and then I got into command. I ended my career in 2004. I was in command at the Naval Pacific Meteorology and Oceanography Center in San Diego, and actually involved in the second Gulf War. And because we were supporting with sailors at sea, and the mission was primarily out of my command at the time, I was interviewed by MSNBC and a few other international outlets about what all that meant and how the sciences were supporting the military mission. So it was a very exciting thing for me, but it was also the end of my Navy career at that point. And then I jumped out and pursued a private sector 10-year career. Moving back from San Diego, we finally decided to live in Virginia Beach, which is where we are today. Lots of military, lots of federal footprints in the area, and this is, of course, where Old Dominion University is. But for the private sector, I worked for 10 years for a company called Science Applications International Corporation, SAIC. Those first two words define me perfectly, science applications. I've talked about my love and passion for meteorology and oceanography, but I'm also an applier. For me, the joy is to be able to take these very difficult disciplines and make good sense of them in an applied sort of way. So it made sense to do that when you were in the Navy. For when I jumped into the SAIC private sector world, I first started out at NASA Langley Research Center, where I was a program manager for about 250 scientists. The job there was, as NASA Langley's Earth Science mission is, the NASA A-Train satellite programs are all polar orbiting, and their job, as it is today, but some of these have been improved upon or upgraded. They are studying the upper atmosphere. The NASA Langley mission is atmospheric science research, the radiation budgets, how it's impacting the ocean, climate change, the modeling comes out of NASA Langley. It also comes out of NASA Goddard Research Center. So my job was really overlapping two NASA centers. But we also happen to have Wallops here in Virginia. That's mainly for rocket launches. But for me, it was a focus on NASA Langley and NASA Goddard. From there, in 2012 or so, I left SAIC and I joined Old Dominion University. Now, part of what I wanted to mention to you is that when I was still in the Navy, President George Bush at the time started the President's Ocean Commission. And the Ocean Commission involved the CNO of Navy from the 1980s named Admiral Watkins. And through Admiral Watkins, we developed a new concept of what the oceans needed today. It was called integration, Integrated Ocean Observing System, IOOS, currently run by NOAA, but it was meant to be a combination of what I'm going to call whole of government, whole of community. You'll hear me mention this several times, but the idea was, can we develop a program that was interagency that linked with the international community of how can we take all of the observations and integrate them in a way that's more meaningful, and we can look at basically the time and space of where these are occurring and how can they be used. So it was an exciting development for me because as I was in the private sector and then I moved to Old Dominion University, that whole idea of integrated ocean observing came into play, as well as this whole of government, whole of community. So at this point, I moved over to Old Dominion University. It was right around the time of Oceans 2012. At that point, the whole idea of climate resilience and sea level rise was just the conversation that was being held in closed quarters behind closed doors. The exciting thing for me was Oceans 2012 opened the door for the public to join in the conversation. Oceans 2012 happened October, Halloween week of 2012. That was the week that just after that conference ended, that Hurricane Sandy struck the coast. So all these conversations about sea level rise and coastal resilience came to roost hard when the impact of Sandy was fully felt, and thus helped promote the things that we were discussing in 2012. It also led to something that I'm going to call a pilot project that some of you on the line know about, but it was the whole idea under the now President Obama administration was, how can we develop regional pilots around the country to study the climate change impacts, since each region of the country will have different climate change impacts. So we were one of about 6. And in our Hampton Roads region, the focus was on our sea level rise challenge, which is amplified by land subsidence, meaning the land is sinking because we've been draining the aquifers while the earth is warming and our oceans are rising. So we have a couple of things that are unique to this region when it comes to sea level rise. But one visual I like to use, and this comes from my friend Colonel Paul Olson. If this were an iPhone 5, this is not a 5, but if it was a 5, the value of the local observations are showing that the width of an iPhone 5 is how much the oceans have been rising over the course of 10 years, and the length of an iPhone 5 over 20 years. It's a good visual because it helps you appreciate the changes that are happening with our tidal flooding, routine tidal flooding now. It's a unique area to study because the ocean currents, the Gulf Stream off our coast, we're seeing as the Arctic warms that the current is slowing. We're seeing the waters rising. We're increasing storms impact and the lowering of the land subsiding. So there's three factors that seem to be the most important factors in why the challenge of sea level rise, coastal resilience is such a big deal. So in 2014, Giovanna and many others at Old Dominion University, since there was a lot of focus and priority in this kind of research, we developed a whole of government, whole of community approach, and we used the campus because there was already so much attention being paid because our president at the time, John Broderick, was interested in multidisciplinary curriculum development and research. We gladly took on this idea of being a convener for all the cities, municipalities, and the federal government. Now, one thing about Hampton Roads, because this was a regional project that we convened on campus, was the federal footprint that exists in the region. There's 1.7 million citizens in the region, 7 major municipalities: Norfolk, Virginia Beach, Hampton, Newport News, so on and so forth. But one out of every 2 jobs in the region, roughly, is a federal job because one, the largest Navy base in the world is 20 minutes away down Hampton Boulevard from campus. We have Air Force Langley. We have the Army Corps of Engineers, where my good friend Colonel Paul Olson was commander and joined our team. The Coast Guard. So, and then there's the NOAA piece, and then the NASA Langley piece. So you can see that we were unique to have this pilot for the 2 reasons of the challenge of the sea level rise rising and the way we could develop a whole of government approach, which was another one of President Obama's priorities. We went for 2 years and we came up with a series of recommendations, many of which have been adopted today. For me, if you recall my comment about integration, the IUS, Integrated Ocean Observing System, that was one of our key takeaways, was the importance, if you're going to do whole of government, whole of community, it's the leveraging and collaboration that is required and the sharing of resources to make that happen. The idea that a Navy base is federal property surrounded by a Norfolk or a Virginia Beach or a Hampton or a Pocosin, that needs to be coordinated whether you're on one side of the fence or the other. So it's logical, but there are natural impediments to that kind of a process. So what we studied in Oceans 2012 that is leading now to our next conference, Oceans 2022, is to take those thoughts and hopefully promote them further. So for many of you, I'm hoping if you will Google Oceans 2022 Hampton Roads, you will see that the Navy is a big part of this. The community is a big part of this. The NASA Langley is a part of this. For the first time, NASA is participating in an Oceans conference. Oceans conferences are run semi-annually, once odd and even years. On odd years are in Europe, and even years they're in Asia, and every fall they're in North America. So with COVID, there was an interruption in 2020, but 2021 and now this year 2022, we're going with a hybrid approach. So at this point in time, we have 600 abstracts. We have 35 countries participating, led by the United States, China, Japan, and India, with a smattering coming out of Europe, South Africa. It should be an interesting conference. The conference theme is Coastal Resilience, Adapting Today to Secure Tomorrow, because the idea of how to mitigate and adapt has national security impacts, especially the way it's impacting the naval base Norfolk. So I would like to leave you now with a few challenges, and I'm again happy to discuss this further with you. When we talk about the sciences, we're talking about something that I remember reading about in a physics book about 20 or 30 years ago, and I can get you the name of the book, but it's the name of the book is Chaos. Chaos theory is a theory in physics where they talk about fractals. Fractals are multidimensional. In other words, Euclidean geometry, if we lived in a world of Euclidean geometry, we all look like circles, squares, and triangles. But the reality of life is that there are details, non-linear details that distort things and make things almost impossible to predict. There is a theory that the atmospheric predictability limit is 2 weeks because the non-linearities in the equations break down the solution. So you cannot, it's just a randomness. But the theory of chaos is that there is order in the chaos. It's a fascinating subject. And I think that as we move into the next decades and with all of you participating, we can figure out how to deal with the non-linearities of life, because that's truly the detail and the beauty of nature and science and how we live. And one way to get to that theory of chaos is integration. I'm hoping that the young minds of today will figure out how to do it. Where we failed, you will succeed. How do we take all the data that's being collected and truly integrate it in a meaningful sense so that we can study the top of the atmosphere to the bottom of the ocean and the complexities of air-sea interaction in between the two. So I call that a grand challenge. It truly is a grand challenge as we develop and we move forward into the century of how all that can benefit mankind and make us all live a more comfortable and safe life. So the limits of predictability is really the challenge that I would leave you with now. If we think we have the equations right, we think we have the theories right, but when it comes to these nonlinearities, for those of you that do math, that are in math, you can appreciate all the assumptions you make to make the equation simple, but that life is not meant to be simple. It's a beautiful, mysterious miracle, and trying to figure that out will be the grand challenge that we will leave you all with. Giovanna, I think that concludes. I'll be more than happy to take any questions. Thank you.
Thank you for talking with us about your career journey. And speaking of that great challenge that you set forth for our REYES participants, what would you tell your 16-year-old self back then of what are some ways that you can work towards hopefully solving some of the challenges that you proposed for aspiring scientists and engineers who are watching?
I was already involved with math, but I would probably tell myself that it's critical that you get that math homework done and understand it, because it's the language of the sciences, Giovanna, and I never properly appreciated as a 16-year-old how important it was before I truly entered in the study of the sciences. You know, even the physics and chemistry notwithstanding, you know, you needed the math, but never understood that meteorology, as it all blends these core sciences together, how important it was. So I would say that. And the other thing is keep an open mind, because every day is a learning experience. As much as you think you know, the more you realize you don't know. So keep that open mind and learn every day.
That's really great advice, Ray. Thank you for that. And I really appreciate how through your leadership over the years, you talk a lot about this whole idea of whole of government. And so I thought it would be helpful if we break it down for our viewers in terms of what exactly does that mean. And one of the ways in which I think about it is this new word of big data, right? It's this notion that we are taking these big pieces of information that, let's say, ODU or maybe oceanographers at ODU may have. And then they combine it with observations that NOAA or NASA has, right? And then they work with people like the Navy who are also working on addressing sea level rise and other challenges. And together, all of that data can be viewed in new ways, and it can help in decision making. So can you talk to us about the importance of that notion of whole of government that you have really led so many of us through over the years, and how it can really help evolve science? Because it could be that somebody that's watching can say, well, how can I make an impact in my small lab at X university? But what if they partner with other REYES attendees, right, who are also working in other labs across the world, and together they can help complete each other's data or even look at data in new ways? So can you talk about this concept of working on a whole of government and how it can be applied to future scientists?
Absolutely. Thank you for that question. I should go back up and say that I had never even heard of that term until President Obama first uttered it, and like it was 2009, and it had to do with the DOD was about to lose a bunch of money. I can't remember what it was called, but it was, it was part of the legislation and the federal budget, and DOD was about to take a hit. And Obama challenged the federal agencies, look, we have to do something. We can't jeopardize our security, our Department of Defense needs. So can we figure out a whole of government approach to share resources and make sure we don't become vulnerable. We leverage from one another in a more effective and efficient way. I thought that was wonderful, but it was a speech, and to some extent there was an exchange of monies and things of that sort, and people would say, sure, it's a great idea, but you have to understand how what is it, OMB, the management and budget process works. Federal agencies get their monies from congressionally legislated funds, earmarked to or focused on a particular program. You have to go to Congress and argue, and then, if you get funding from Congress, then you have to follow the bookkeeping to ensure that that money is being, taxpayer dollars are being spent wisely and efficiently. The problem is that stovepipes programs. So that's where we are today. We have, approvals, and we have budgets, and we have to execute programs, but it does not lend itself to cross collaboration, if you will, because everybody's trying to protect their turf because they don't want to lose money. And then they have to account to Congress if they aren't doing what they said they would do. So there has to be a different mindset here about how can we go like this, and work on each of these vertically aligned stovepipes and make them more effective in an integrated fashion. So for science, you see, everybody's got their values and their priorities for these individual programs, and they're all well-meaning and well-intended. It's just that it's a very inefficient way to improve the understanding of science. If we could integrate, and truly collaborate, and that's the challenge. I think it's there. I think this new generation will figure that out because, well, I should also say that, see, whole of government means Commonwealth of Virginia and municipalities. Well, the Constitution separates that. You're not supposed to, the federal government is only supposed to do so much because you don't want a dictatorship, if you will. And the state has certain, so everybody has their lanes of responsibility. Whole of government sort of challenges that constitutional notion. And it's, the Constitution is written for a purpose, but it makes it difficult to execute a whole of government approach. So the best thing we can do is have those conversations, exchange the ideas we have, exchange those big data that you're talking about. Data, you have to account for it, but there's ways and means with technology of today and the creative solutions that we have from young minds to get that data out and share it for the benefit of more than just that particular program. Does that make sense?
It does make sense. Thank you for sharing that. And, I think you mentioned earlier about why President Obama was perhaps worried about security. And so if you want to maybe talk to our audience a little bit more about what in particular he was worried about, I'm assuming it has to do with the fact that here in Norfolk, which is so close to the ocean, it's actually the second We're in the second spot in the US that has, that's closest to the ocean. And so it means that sea level rise and any of those threats are top of mind for us. If it rains any day, we're trying to look for new routes because we can't actually like go past a certain road to pick up our kids in school. So the threat of sea level rise is actually something that is top of mind for people like us in our region. But also our region is the world's headquarters of the Navy. And so we have the largest naval presence in the world right here in Norfolk. And so I imagine that from a security piece, the federal government is worried about what this means for its fleet operations, correct? What does increases in sea level rise means? What threats do impending storms have? Am I correct? Or can you maybe talk a little bit more about that?
You're absolutely correct. This is the largest Navy base in the world, Norfolk Naval Base, but we are not the only one. Remember, Navy is global, and the importance of Naval Base Norfolk is not just the Atlantic Fleet, but because they are so large with the seniority of admirals, there are responsibilities that this Norfolk Navy footprint has with the Pentagon for global Navy. So global Navy is worried about global Navy flooding and coastal erosions and how it's impacting tactics and operations for amphibious warfare. Just as an example, where do you land your troops? When the waters are changing. So there's more of a responsibility in Norfolk on top of our local concerns and local priorities and challenges, as you've described. So when Obama talked about whole of government, he had that in mind because in his second term, remember, he prioritized climate change in his next 4 years, and he wrote that doctrine, I think, that came out in 2013 or 14, and that's what started our journey in 2014. And we were just thinking again about Hampton Roads, but the idea was that we could look at the Hampton Roads example and apply it to what's happening in Guam, where there was a similar challenge with sea level rise, and what was happening, in Diego Garcia, and how we were going to deal with the Taliban and the Middle East, all of these, because everybody is impacted. It doesn't matter where you are, it's just that we happen to be impacting because we have, again, the three factors of ocean current, of global warming, of coastal subsidence. So we just happen to be hit by three factors, but it's happening everywhere. So the idea was use the Navy Authority here in Norfolk to help with global Navy concerns.
I think one takeaway too is that just like you did with that pilot project that was regional in nature, but you collaborate with people across all areas of government who also were exploring the challenge and wanted to find solutions. And then you developed best practices that, although they were developed here locally, the idea was that you could take the pilot project that you led from the White House, and then you could take that information and apply it, like you said, anywhere in the world. And so again, it's just this idea that for scientists to be thinking about that, no matter where you live in the world, usually your community is dealing with a problem that you can work towards solving. And that knowledge that you're generating and that information and those practices can then be taken as a playbook that then can be applied. For example, in our case, we are a coastal community. So you can take what we're learning here about coastal and water resilience and flooding, and then apply those to other coastal areas across the globe. So again, I just always want to encourage our scientists to keep an open mind and know that their work can be significant no matter where they are in the world, just like yours has. And so what are some of the things that inspire you to keep learning, and how do you keep learning? I know that you're co-chairing now the Oceans 2022 conference that you spoke about, which, by the way, is endorsed by the United Nations, which I think is fantastic. Again, just how your work is always impacting global communities around the world. What are some ways that you stay abreast of the latest in technology and you stay abreast of learning to help moving forward research?
I think just staying involved and engaged, Giovanna, because the nice thing about my career is that I have friends all over the world. I mean, I've got from all walks of life, and we talk all the time. I've stayed, I love people. I love to communicate. I love to learn. And there's an expression I remember as a kid: the more you know, the less you realize you don't know, because at the end of the day, you just want to help and be productive. And for the example of Oceans 2022, we chose coast resilience for the obvious reasons of having people come and talk about their offshore wind development and how they're dealing with all the things we deal with here. So with 500 abstracts and probably 2,500 people, but some of them will stay remote and won't travel, but we'll hear them either live or with a video. It'll be an exciting time to exchange and learn what they're all doing. And they all recognize, most of them, what the unique challenges we have here. So they're interested in learning how we're dealing with it, especially. So the other thing is the submarine community is a very large stakeholder this time around in 2022. We didn't have the submarines involved in 2012 the way we do now. So this is a chance to really look at unmanned systems, how the submarine force views the future, how they're dealing with, remembering how I was talking about the ocean and how it fluctuates with the currents and densities. So there's surveillance requirements that are coming, and the whole idea of they really want integration in a big way for the all the same reasons we talk about for underwater operations. So they will be involved, and that's bringing in Naval Sea Systems Command and a whole bunch of Navy engineers and scientists that we did not have before. And it only makes sense that they come because of Norfolk Navy Base for one, but this is where headquarters is. So if they can figure it out here, we should be able to figure out globally. So I hope your students will pay attention to Oceans 2022, because should be a lot of exciting developments that come out of it.
It sounds great. And again, it's really wonderful to see a global presence and also having scientists from NASA that are participating for the first time this year. And how do you foresee that some of this research will help prepare us better for future changes in climate change that I know have been accelerating so fast? I was just reading this morning how, unfortunately, in California, they're expecting some historical storms that may last about 2 weeks or so, just because of the nature of what we're seeing in terms of climate change. So can you tell us how some of this science may advance and help prepare us in other ways?
Well, the two words we used in the pilot were mitigation and adaptation, as you recall. Mitigation was, how do you mitigate the near-term impacts, which is more what city managers do, for example. The next weeks or two, the next storm, how do you mitigate the impacts, versus the adaptation piece, which we viewed as a city planner might, what's going to happen in the next decade. And so the combination of these two perspectives is where I hope the science can walk us forward, because there is this timeline. It's a continuous timeline. You can't just, you go from point A to point B along a timeline, but everything's, that Mother Nature doesn't know how to stop and start and stop and start. It's just all continuous. So the whole idea of synchronization along a timeline, as well as the data and how we integrate big data with real time and climate and historical, I should say, right? So these things come together time and space wise, that I think science will help us truly make more effective decisions about that timeline, the mitigation and adaptation timeline that really it's all overlapped. Does that make sense?
It does make sense that we work at the same time for mitigation, but also helping the community prepare and adapt to changes that are already happening, right?
Exactly.
So with that said, are there any questions that you wish we would have asked you about some background, or things that maybe you wish you knew at 16 or 18 years of age in terms of oceanography, meteorology, or climate science?
I think maybe one question I would have suggested is, it's not a clear question anybody might have, but knowing myself, there were clear obstacles in my path to get to where I wanted to get to. But I had a dream, and I had a vision, and it meant leaving my home and my family at the age of 18. And I was the oldest of 5. And I often wonder, as I go back, because I went to my high school reunion, I saw all these folks that I hadn't seen in 50 years. But you know, we're all fruits of our decisions. And my decision was I had to leave at 18 in order to achieve my career goals and objectives. If I had not moved, there was no way I would have been able to do what I did. And for better or for worse, I think I made the right choice, but you can't second guess yourself. You got to keep moving forward. So maybe the one question I might have asked myself is some of that, like what really drove you to make those hard decisions, just to embark on a journey that really required a lot of sacrifice and second guessing for a time. But I had to keep that goal in mind, and I kept that vision, you know, looking ahead. I didn't try not to look back.
That's really good advice, that sometimes we have to make those hard decisions to leave the comfort of our homes in order to pursue studies that will help make a difference, not just in your life, but also of communities around you. So that's really good advice. Thank you for that. And one of our participants wrote this really nice note that I thought I would read to you. It says, Ray Toll is the real deal, incredible asset to our region. And I would actually say an incredible asset to the world. I think so highly of you. You're so humble in what you do, but also so distinguished in your career. And I always appreciate how you have taken the time to help others around you, and that you're always looking for ways to increase collaboration. And so we're so fortunate to have you today joining us and sharing your talents and your science with us. So on behalf of Old Dominion University and the REYES program planning team, I would like to thank you, Ray Toll, one more time for joining us today. And we are going to continue to follow your innovative work and advances in ocean science and coastal resilience for many, many years to come. I'd also like to extend my gratitude to the Office of Distance Learning for their support of this event. And to our audience, thank you for tuning in. Today's session has been recorded, and if you'd like to watch it again or share it with friends, you can access it from the ODU REYES website. This concludes today's program, and we hope you have a wonderful day. And Ray, thank you so much again for sharing your knowledge with us. We so appreciate having you today.
My distinct pleasure. Thank you.
Thank you. Have a great day, everyone. Bye.
Bye-bye.